Hello everyone, welcome back to our channel Shviyogi Academy and welcome to this class on Newton's second laws of motion. I am going to make the concept really easy for you and clear for you. I am sure after watching this video you will find super easy. Okay, let us begin. Now we discuss with the Newton's second laws of motion. Laws of motion. Newton's second laws of motion. The first statement is that the Newton's second laws of statement is that we know that the second law of motion, the second law of motion, the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Okay, the Newton's second law states that the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force direction of it. Suppose an object is here. When we applied the unbalanced force, it shows in a change in their position, or that is nothing but a momentum of an object. This is the Newton's second laws of motions. Okay, see, mathematical derivation, the mathematical derivation of Newton's second law is, now we are going to derive the mathematically statement for this Newton's second laws of motion. We know that momentum is nothing but that is the product of mass and velocity. Momentum is represented by letter P, so that is product of mass and velocity. Okay, so initial velocity of an momentum is represented by m. Product of mass into velocity, that is nothing but a momentum, no? So initial momentum, that is represented by letter P1, so m into u. Here P2 is equal to final momentum of velocity. When the bowler casts the ball in a cricket field, initially they hold hands in opposite to the batsman, and afterwards holding the ball, and he moves backward his hands. Okay, he moves backwards his hands with the ball. So this one is the initial momentum of an mass of an object. This was the final momentum of an object. So yeah, here P1 is equal to m into u, P2 is equal to m into v. Here m is common for both because there is no changes in the mass of an object when he hold the ball in this position in front of the opposite to the batsman, and next he moves his hands backward. That's why ball object mass is same in this momentum. Change in momentum, time taken, that is t, from this point to this point. Okay, so P2 is equal to, called as equation number 1, this is called as equation number 2. So change in momentum is equal to change in momentum, that is represented by delta P, so is equal to subtract initial momentum from final momentum, that is P2 minus P1, called as equation number 3. Substitute equations 1 and 2 in 3. In 3 we get delta P is equal to mv minus mu. So m is common in both terms, that's why it keep outside from the bracket. Rest of things are in bracket v minus u, called as equation number 4. Okay, now apply rate of change of momentum, rate of change of momentum to equation number 4, to above equation, that is equation 4. We get delta P divided by delta T, that is rate of change of momentum. Time is divided on both left and right side of this equation number 4. So we can write m into v minus u divided by t. So we know that rate of change of momentum, that is nothing but force F. So m into v minus u divided by t. So we know that F is directly proportional to the, now F is directly proportional to m into v minus u divided by t. We know that acceleration is equal to v minus u divided by t. So substitute in this equation number 4 and 5. This is equation number 5. So a is equal to v minus u divided by t, substitute in equation number 5. So we get F is directly proportional to m as it is v minus u divided by t. Write a in place of v minus u divided by t. So F is equal to directly proportional to m into a. Now we can write F is equal to k into ma. Okay, write k instead of proportionality constant. Here k is a proportionality constant. So suppose when we say 1 Newton of force is said to be accelerate an object accelerate 1 kg of mass at 1 meter per second square. So called as equation number 6. 1 Newton is equal to said to be accelerate an object 1 kg in 1 meter per second square. Okay, 1 kg of 1 Newton force is applied. This object is at 1 kg mass. It accelerates in a 1 meter per second square. Okay, so called as equation number 7. Compare equation number 6 and 7. So we get F is equal to m into a. Okay, F is equal to k into m into a. Compare this equation 6 and 7. This is equation 6 and 7. Compare it. So we get 1 Newton, write F. 1 Newton is replaced by F. So we write F. 1 k is replaced by 1. So 1 kg is replaced by m. 1 meter per second square is replaced by a. So F is equal to 1 is multiplied by anything. We get that F is equal to m into a. This is the Newton's second laws of motion. The momentum of an object is proportional to the unbalanced force applied on it in the direction of the force. Okay, please do subscribe and click on like button and share it out with your friends. Thank you.